All right. So here is how you use what we've been doing lately. So what have we been doing lately? We've been doing composite arguments for cosine and sine. They're also called angle sum difference. Angle sum, and then if it doesn't say the word sum, it might be difference. Why? Because you're taking the difference of angles or the difference or the sum of the angles. So what does that mean? That means I either have sine A plus B or sine A minus B. We've also been working with cosine A minus B or A plus B. Do you remember what sine A plus B was or is? Oh, you don't remember? Okay, you'll have a note card, but make sure for your exam you will not have a note card. So make sure that you know it by then. Sine A plus B is sine A, cosine B. You keep the sign, so plus cosine A, sine B. And then if it's a minus, if it's A minus B, then you just change the plus to a minus. For cosine A plus B, do you remember what that one is? Cosine A, cosine B, plus or minus? Minus sine A, sine B. And if it's a cosine A minus B, then it's cosine A, cosine B plus sine A, sine B. So there it is. So sometimes they're called angle sum difference if you look at a textbook or if you Google it. All right. In time, we're going to do a UH quiz. We're not there yet. So this is coming from UH. See, it says extra from UH. It says use the appropriate angle sum formula to simplify the following expression. So here's how you tackle these guys. You look at it and you're like, oh wait, cosine, cosine, sine, sine. I notice that 4x comes out again right here. I notice that 6x comes out again right there. Wait a minute, that's like an A, that's like a B. So this is just like this right here. Do you guys see that? Well, because it's just like this one, I can replace all this with a single cosine. Which one is it? Cosine A plus B or cosine A minus B? Cosine A plus B. So I can rewrite this as cosine. What's the A? Yeah, not everyone at the same time. 4x. What's the B? 6x. There it is. What's 4x plus 6x? And there's my answer, guys. I made this one free response, but I think on the UH quiz, it's all multiple choice and you circle the cosine 10x. You could also let the answers give you the answers and type this into Y1 and type every single answer choice, Y2, Y3, Y4, Y5, and then see which one matches the graph. But why do all that when you can just, see? Cool or not cool? Okay, I think everyone finds those pretty easy. So here's where you're going to need your A game. Relax. UH is harder than the delta. The delta that you're going to have today, they're all acute angles, so you don't have to worry about where the angles are. Chop, I have no idea what you're talking about. Okay, I'm recording this, guys, so if it's best for you to just observe and take it in, then just observe, and then you can later on write it down, right? So I'm recording this, so just observe. So given cosine x is 1/6, and notice that angle x is in quadrant 1, Q1, and cosine y is 1/4, and y is in quadrant that looks like 4. So I'm going to color code this. That's quadrant 4. Find cosine x plus y. Your first move, what's the first move? Do you know what cosine x plus y is? The x is like A, the y is like B. So I'm going to write over here, cosine, before you do anything, cosine x plus y. What is cosine x plus y? Cosine x. What do I write next? Cosine y plus or minus? Minus what? Sine x, sine y. And I guess some of you may be thinking, why can't I just find the angle x, find the angle y, add them up, and then, yeah, I guess you could, and then let the answers give you the answers. But if you want the exact answer, here's how you do it. Do I have cosine x? Yes, it's given to me. It's that one in red. Yep. Do I have cosine y? Yep, it's given to me. It's the one in blue. They do not give me sine x. They do not give me sine y. Do you guys notice that? So we're going to do something called SOHCAHTOA. Do you guys remember that? Yeah, it doesn't go away, guys. SOHCAHTOA. Once you're beast, you don't have to write it down, but it always helps to write it. I'm going to do quadrant 1 first. Exaggerate quadrant 1. Draw a reference triangle from the origin, not to scale. Today, you can tell it's been a long day when you can't spell scale. There we go. All right. Angle X is this one. Label your angles. That's angle X. Cosine is what over what? It starts with an A. Cosine is what over what? Adjacent over hypotenuse. So what's adjacent to angle X? This guy right here, 1. What's hypotenuse to angle X? Well, what's always hypotenuse? That's my right angle. There it is. I need the vertical displacement to be able to figure out sine of X. So I need this guy right here. So to figure that out, it's just Pythagorean theorem. Do you guys see that? I'm going to take the shortcut. The hypotenuse is always the biggest leg. So you go square root of 6 squared minus 1 squared. So this is square root of 35. 36 minus 1 is 35. Are we okay? All right. Check it out, guys. From that, I already know cosine X. It's given. So cosine X is 1/6. I'm going to put the words given. I guess you could also look at this triangle. Now I'm going to get sine X. Sine X is opposite of our hypotenuse. Square root of 35 over 6. Happy face. Are we still okay, guys? Nothing crazy, right? All right, look at the one in the blue. So now I already got sine X. I need sine Y. So sine Y, I'm going to exaggerate quadrant 4. Here, draw a reference triangle. This is actually angle Y right here. But I'm going to use the reference to help me out. So I'm going to put Y of R. And it says cosine is adjacent over hypotenuse. So this guy here is 1, not to scale again. The hypotenuse is 4. The hypotenuse is kind of like a radius, so it's never negative. Unless you're talking about polar, but we're not there yet, so don't worry about that. Hypotenuse is never negative. Write that down somewhere. The hippo is never negative. Okay, I want this distance. That's a square root of 4 squared minus 1 squared. So square root 4 squared is 16. 1 squared is 1. So 16 minus 1 is 15. Because I'm in quadrant 4, I'm going to put a negative in front of the square root. The most common error is you guys put a negative inside. It's not, put a negative on the outside. We're not working with imaginary. Are we okay, guys? All right, look, we got it, guys. Given, they gave cosine Y, they gave it to us. 1/4. I'm going to write given, the word given here, just like before. But now I have sine Y. And sine Y is opposite of our hypotenuse. So negative square root of 15 over 4. How do we feel? All right, guys, we're done. I'm going to take this guy. I'm going to rewrite it right here. So I'm just going to write cosine X, cosine Y, minus sine X, sine Y. I'm going to write what each one is. What was cosine X? 1/6. What was cosine Y? 1/4. Sine X. What was sine X? Square root of 35 over 6. What was sine Y? Thank you. You guys are real loud today. We're done, guys. You're just doing arithmetic now. Here we go. 6 times 4, 6, 12, 24. 6 times 4 is 24, so 1 over 24. Minus, negative times the negative is a positive. Square root, what's 35 times 15? I don't know. Well, let's have it. We have a calculator, guys. Take my calculator. Yeah, I'm just multiplying 35 times 15, the inside the square roots. Come on, calculator. Unless you guys have it. You guys have it? Second memory, 712. 35 times 15. 525. So square root of 525 over 24. So my answer is 1 plus square root of 525 over 24. I look for that answer and I don't see it. I guess you can let the answers give you the answer, see what that decimal is, and figure out which one of those is that same decimal. All right. I take the 525, and it's easy to break it down, guys. Look, you're just going to go like this. So 2 numbers multiply to give you 525. So it's like saying this. You don't have to write this down, guys. Just listen. So it's like saying x times y equals 525. Look, if I divide by x, I can type this into my calculator. And then if I look at a table, both the x and the y, when I multiply them, will give me 525. So I go to my calculator, and this is just a hack, right? 525 divided by x. And I just go to my table, guys. Second table. So look, every single one of those numbers multiply to give you 525. Chav, why did you do that? I am looking for a perfect square root. So I just go to my perfect square roots. I know that 4 is a perfect square root, but I don't want to have a decimal. I want both of them to be integers. So then I go to 9, or I keep looking. I can also look on the right-hand side. I still don't see it, so no. I'm looking for 2 integers. No. There it is. I just see it. Do you see it? Look at 21. When x is 21, the y value is 25. 21 times 25 gives you that number. Child, why'd you stop there? I don't understand what's special about 25. 25 is a perfect square root, guys. What's the square root of 25? 5. So when I come back here, check it out. When I come back here, guys, I can write here. I know Delta does it like square root of 21 times square root of 25. But look, there's my little branch. This one's a perfect square root. And the square root of 25 is 5. So I can write it like this. 1 plus 5 square root. And what do I still have left under the square root? 21. All this over 24. And then look at that. There it is. How do we feel, guys? Okay. Don't worry. We're going to do another example because these can be tough. So it says, so let's see if we can do this now without all those references. I'll still reference them, but I'll just do it in one color now. And no yawning, that's a demerit. YouTube, I do not give my kids demerit, so don't give me a thumbs down for that. I'm talking to my fans. No? Okay. Given sine x is 3/10, so this is in quadrant 2 between 90 and 180. And then sine y is negative 2/3, and that's in quadrant 3. Everything in quadrant 3 is negative, except the hypotenuse. Find sine x minus y. Okay, before you even start, you got to start with sine x minus y, because if you don't know what sine x minus y, forget it. So, sine x minus y. Tell me, what is that? Give me the composite argument property. It starts with s. So, sine of sine x. What's my next move? Cosine y, plus or minus? Minus. What's the next one? Now we already have sine x, so cosine x, and then what's the next one? Sine y. There it is. Start with that. Then I'm going to go to this one right here. This is angle x. That's in quadrant 2. So exaggerate quadrant 2. There's quadrant 2. Here's my right triangle. This is the real angle x, but we're going to use a reference to help us out. And sine is what over what? I was going to say adjacent, but I was wrong. Sine is opposite over hypotenuse. So opposite 3, hypotenuse 10. So right now we're focused on this one. Let's just figure this one out. So this horizontal displacement is the square root of 10 squared minus 3 squared. This Pythagorean theorem. I'm just going right down to the, to the answer. 10 squared is 100, 3 squared is 9, so there's a square root of 91. But because it's in quadrant 2, it's going to be what? Negative. So put negative square root of 91. Is everyone okay with that? Okay, put in their notes. It's in quadrant 2, that's why it's negative. All right, so let's see. What do I got? I already got sine x, so I need cosine x. So I'm just going to write cosine x down here. So cosine x is, cosine is adjacent over hypotenuse, negative square root of 91 over 10. All right. Now I'm going to do the other one, sine y. Make sure you label your triangles, guys, so you don't get confused. 180 to 270, that is quadrant 3. So I'm going to exaggerate quadrant 3. There's quadrant 3 exaggerated. Reference triangle. They give me negative 2/3, so I'm going to use my reference. This is your reference. That's not the real y angle. Sine is negative over hypotenuse. This is a opposite over hypotenuse. That's a negative. The hypotenuse is never negative. And here we go, guys. The horizontal displacement. Square root of 3 squared minus negative 2 squared, if you want to be technical. So 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. So put a 5 and a negative on the outside because you're in quadrant 3. Does that make sense? What's up?
I think the more you place the numbers for quadrant 3, like with the negative 2 and 3.
Oh, because I'm using sine. See how they told you sine is negative 2, 3? So the 2 is the y value, opposite over hypotenuse. So here's the y, opposite, 2, negative 2, and then hypotenuse, 3. The hypotenuse is always wherever that right angle aims. Does that make sense? No. Ask, miss, please, I want you to ask. Check it out. No, I'm going to say it again. Okay, so this is my angle, my reference angle. And sine, see how it says sine is negative 2/3? Is opposite over hypotenuse. So here's how you work opposite. Wherever this angle is, you just go, oh, what's opposite of that angle? Boom, right here. So this is opposite. And then wherever the right angle aims, see how that aims here? That's always your hypotenuse. Always, always, always. That makes sense? So opposite over hypotenuse. Yeah, no, thank you for asking. Yes, please ask. Please, please, please. I wish you guys could read my mind, guys. I don't have the vocabulary, I don't have the vocabulary to express my emotions. But I wish you guys could read my mind. I want you to ask. That's why we're here, right? That's what your teachers are here for, guys, to help you understand. So please ask. All right. I need cosine y. So I'm going to write cosine of y. And cosine is adjacent over hypotenuse, right? So adjacent, what's adjacent? Not everyone at the same time. What? I just heard mumbles, guys. Yeah, negative square root of 5 over hypotenuse, which is? All right, we got everything, guys. We got everything. I'm going to come over here, and I'm just going to rewrite this expression down here. I'm going to write sine x cosine y minus cosine x sine y. All right, here we go. Sine x was, I think that was given. Yep. What was sine x? 3 over 10. You can also get it from the picture up here. Cosine y, I had to find that. What do we say? What do we get cosine y to be? Negative square root of 5 over 3. Minus, now it says cosine x. I go back to my x here. Well, we never go back to our x's. But this, I'm talking about math like now. So you go to this. So negative square root of 91 over 10. Yeah, don't go back to your x, guys. You're just asking for trouble. You broke up with them for a reason. So, yeah. Okay, sine y. Sorry, YouTube. We do math here and life. All right, sine y. What's sine y? Negative 2 over 3. And you're done. Now the rest is just simple arithmetic. So let's see. Positive times a negative is a negative. Well, check it out. The 3's cancel out. Bam, bam. Negative square root of 5 over 10. Negative times the negative is a positive, but then I still have another negative there, so that minus sign stays. And I kind of, okay, I'm going to slow down because some of you guys don't like this when I do it, but I see a 2 in the top and I see a 10 in the bottom. So I like to reduce right now. That's me. So I like to go 2 goes into 10 5 times. Do you see what I did? And then 5 times 3 is 15. So this is going to be square root of 91 over 15. And there it is. Okay, it looks funny, but I see the answer. They wrote it like this. They wrote a fraction first with the radical on the side. So negative 1/10 the square root of 5 minus 1/15 square root of 91. Maybe it's a programming issue. Who knows? But that's the same as this. How do we feel, guys? Okay. So the rest is just practice. Now, real quick, before you go on your adventures for Delta Math, I want to talk about some topics that you guys have been doing or getting wrong from observation yesterday. Some of you, when you do this, square root of 5 minus square root of 2, that is not square root of 3. I see a lot of that. What else do I see? I see, all right, 3 square root of 5 plus 2 square root of 5. That you can add, see, because now you have a common base. 3 plus 2. Now that would be 5 square root of 5. That's okay. What other mistakes do I see? Oh, yeah. Square root of 3 times square root of 2. Laws of exponents comes into play. That is fine. You can do square root of 3 times 2. So 3 times 2 is 6. You can do that. That is acceptable. That's acceptable. This is not acceptable. Cool or not cool? All right, guys. That's it. Go log into Delta Math. See if you guys can practice doing that activity. And we're done. Ask me for help if you need help.